Here in this video, we are talking about the terminal voltage of a cell or a battery. First of all, battery is a device who can drive the energy, who can drive the electric current or charges in a circuit, right? So typically shown this way. This is the positive plate of a battery. This is the negative plate of a battery. This is connected in any electric circuit having some resistance. So this battery helps to drive the charges in this electric circuit from the positive plate to the negative plate, and that will be keep on happening, right? As we have discussed in the earlier video, if the battery is ideal, its internal resistance is equal to 0. There is no opposition. In that case, the potential drop across the external resistance is equal to the EMF of that battery itself. But the batteries are not ideal in general, so they have some internal resistance. Let it has an internal resistance small r. So if I have to draw an equivalent circuit, this is an external resistance, this is the battery, but this battery also has some resistance which is opposing the flow of the current, which is being called as an internal resistance. Thus internal resistance acts like a series resistance to the battery. So what happens as there is an extra resistance called as an internal resistance, there is a potential drop if E is the EMF of that battery. If there is no internal resistance, that is this case, if it is an ideal case, entire EMF is the potential drop across the external resistance itself. But because there is the internal resistance, there is some potential drop across this external resistance. There is some potential drop across this internal resistance too, though it is a very small value. Therefore, the total EMF can be called as potential drop across the external resistance plus the potential drop across the internal resistance. As internal resistance is acting like a series resistance, the current is same across both of them. The same current will go and come back. So we can say the total EMF of the circuit is potential drop across the external resistance is I into external resistance, that is the Ohm's law. Potential drop across the internal resistance is I small r. So you can call the potential drop across the external resistance as potential difference V plus IR. So what is the potential drop across the resistor, external resistor, when it is connected to a battery is E minus IR when the resistance is drawing the current from the circuit. This is how we can derive an equation for the voltage across a resistor. That voltage is called as terminal voltage. It is obvious that for any non-ideal battery, terminal voltage when it is drawing current from the circuit is less than EMF, and there is some loss of voltage. That loss of voltage is being referred as a voltage drop across the internal resistance of that battery. That's how we have to study. Thank you for watching.